Advanced Engineering Mathematics by Wylie Barret, 5th edition. Problem number 16 on page 106. Find the complete solution of the equation which satisfies the given condition. Y double prime plus 4y prime plus 5y is equals to 20 e to the x, where y is equals to y prime equals to 0 when our x is equals to 0. We remember that our y is equals to yc plus yp, which our yc is our constant coefficient solution and yp is our particular solution. Solving for constant coefficient yc. In this case, we first look for its characteristic or auxiliary equation. Given the equation y double prime plus 4y prime plus 5y is equals to 20 e to the x, it would now become quantity ab squared plus bd plus c times y is equals to 0. To determine or characterize the non-trivial solution, we would assume y is equals to e to the mx, y prime is equals to m e to the mx, y double prime is equals to m squared e to the mx. Now it will become m squared e to the mx plus 4m e to the mx plus 5 e to the mx equals to 0, where m is a constant to be determined. But because all derivatives of these functions are alike except for non-numerical coefficient, we will factor out e to the mx from every term, so we have from m squared e to the mx plus 4m e to the mx plus 5 e to the mx equals to 0. It will now be e to the mx times quantity m squared plus 4m plus 5 is equals to 0. Using quadratic equation, we will get its roots. M is equals to negative 4 plus minus square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. Our m would become negative 2 plus minus I. Since the nature of the roots of the characteristic equation is a conjugate pair complex roots, m1 is equals to negative 2 plus I, and m2 is equals to negative 2 minus I. Thus, yc is equals to e to the px quantity c1 cos qx plus c2 sin qx, where p is equals to negative 2, q is equals to 1, so our yc is equals to e to the negative 2x quantity c1 cos x plus c2 sin x. Solving for our particular solution yp, we would use the method of undetermined coefficients. We would assume that y is equals to ae to the x, y prime is equals to ae to the x, y double prime is equals to ae to the x. Then we would substitute it to the original equation to get ae to the x plus 4 ae to the x plus 5 ae to the x equals to 20 e to the x, which our a is also a constant to be determined. Now we would get 10 ae to the x is equals to 20 e to the x. Our a is equals to 2, so our yp is going to be 2e to the 2x. Therefore, yc is plus yc plus yp is equals to y. Since our yc is equals to e to the negative 2x quantity c1 cos x plus c2 sin x, and our yp is 2e to the 2x, So our y would become y is equals to e to the negative 2x c1 cos x plus e to the negative 2x c2 sin x plus 2e to the 2x. But since earlier we have a given condition, that is y is equals to y prime equals to 0 when our x is equals to 0, so we are going to substitute the values of y is equals to 0 and x equals to 0 to our complete solution y. So we would now get a value of c1 is equals to negative 2. In the same manner, we would also substitute the value of y prime is equals to 0 and x is equals to 0 to our given equation y prime, which will also get the value of c2 which is equals to negative 8. Now we have our complete solution. Since we already have the value of c1 equals to negative 2 and c2 is equals to negative 8, so our final answer of the complete solution is y is equals to negative 2 e to the negative 2x cos x minus 8e to the negative 2x sin x plus 2e to the 2x.